Hi, I'm Lou. Welcome to CNC the Math Tutor. Today's video is part one of a series of short videos I'm going to put out to try to uncover the mysteries of the distance formula. I hope you enjoy it. Okay, so if you've seen that mess of a formula, you know that we call that the distance formula. And if you're like me, I don't know, I like to see things. I'm a visual kind of learner. I'm a visual kind of teacher. I like to show what you're doing, and I think when you're just dealing with a formula, you're not really understanding or grasping the visuals of what you're trying to do. So that's what I'm trying to focus on in this video, is to give you a visual. So this way you don't feel so frustrated when you come out with the wrong answer when you calculate distance of 2 points. So let's take points A and B that you see here on this little graph that I put on the side. If you're trying to find distance between those 2 points, you're finding a line segment that connects those 2 points. The problem is it's hard to measure that if you don't have a ruler or if you don't have a compass, even though you can, but the compass is not going to tell you how long it is. That's why the distance formula was developed, is to take those 2 points and calculate a distance between. So if you just use the distance formula, you're going to need to know the coordinates of those points, which I will show now. And what we do is we then assign values to each of those coordinate points, x1, y1, and x2 and y2. Now, assuming that you assign them correctly, which doesn't always happen, a lot of people tend to assign them incorrectly, or they don't know where to put the x1 and the y1. Let's assume that we do that correctly. The next step would be to put them in the formula right here. And this is great because you have values to place. But when I see all these negatives and subtraction symbols, it's just a recipe for disaster. A lot of people make mistakes here. It's because of the fact that when you're entering in the calculator, if you don't put a negative right and a subtraction right, you're going to have a disaster. But there are times when people do this right. They substitute it perfectly. They have parentheses perfect. The calculator gives you the exact number that you needed to do. And what do they forget? They forget about the radical sign. This just leads to all sorts of problems with the distance formula, and I would like to remedy this problem by showing you a visual way to solve this and an easier way, in my opinion. So let's go ahead and try it out. Okay, so I want you to just look at the grid, and let's imagine that we have to find the distance between A and B, and let's imagine that we don't even see the distance formula up there. If I wanted to get from A to B, I think I can consider that there is a horizontal distance right there, and it's represented by that line segment. I don't know what the value is, but I know that we can represent it with a value. So for now, I'm going to call it A. And that would be the distance between the x values, so I'll put A right here. And I'll throw a squared on top of that because that's what the formula says to do. Then I would consider to get from A to B, I'd have a vertical distance. I'll represent that with this magenta line. And again, that's a value. I'll call it B. And that's the distance between the y's. I'll call that B, and I'll square that too. I'll put a plus sign between them, and now you might start to see something familiar. In fact, if I call that a triangle, and I asked you what kind of triangle it is, you would definitely say that's a right triangle, because this angle right here is clearly 90 degrees. And if we have an A and we have a B, chances are we're going to have a C. I would use that to represent the distance between A and B, and I'll write it over here. Only if I follow the formula, I wouldn't square that C. I would keep it the way it is, and I would throw this gigantic, ginormous, ugly-looking radical symbol, which clearly I did not draw nice and neat, but I would put that over those values. Now, if I don't like that big radical symbol, I can actually get rid of it. If I was to square this entire right side of the equation and also the left side of the equation, because whatever you do on one side, you have to do to the other, I would end up with c squared equals a squared plus b squared. If you are learning about the distance formula, I guarantee that you know what this means. This is another way of looking at the Pythagorean theorem formula. Usually when I show a student this, I ask them if they've heard of the Pythagorean theorem formula, and I've never really sat with a student and they told me that they've never seen that before. It's usually what comes before the distance formula anyway. So knowing it and being able to apply it to a graph or a coordinate plane is very fantastic. All right, keeping the the Pythagorean theorem in mind, I'm going to keep the yellow triangle on the screen just to give you a better visual of what we're looking at. And now I'm going to actually count these values. If I go from A to B, and the x values I'm looking at are from -3 to 5, I have 3 in the negative direction, 5 in the positive direction. That gives me a total of 8. So I would say that's 8 squared. In the vertical direction, I'm going from a -7 to a +8. There's 7 below, 8 above. Add that up, you end up with 15. So that's 15 squared. I'm adding that together. Well, we know this, we're finding distance, and before I squared the c, so I'm just going to use a d to represent distance, even though I know it's the hypotenuse. And I'm going to also square that, because that's the way the formula originally looked. So my next step would be to square the 8 to give me 64, square the 15 to give me 225, add them to give me 289. That's our d squared. But we need to get rid of the square. So take the square root of both sides, and you're left with a distance of 17. So I'll put a 17 up here, and that is the distance between A and B. I didn't have to plug anything into this formula. I used what I knew about the Pythagorean theorem. I counted boxes, and there you go. An easy way to find distance. I find it to be better because it's visual. I can see it. And in the next part of this video, I'm going to show you that even if you had ridiculously large numbers, you could still use this concept to be able to find a distance between 2 points. Thanks for watching. Stay tuned for part 2 of this series coming out real soon. And if you enjoyed this video, please give it a thumbs up and subscribe. There'll be more to come, I promise.